In this lesson, we're going to continue the practical applications of trigonometry problems. So we're going to be kind of specifically looking at how do we use trig to determine layouts. I'm going to look at using holes for one of them. It could apply to gears as well in order to find distances. So for the most part, we're going to look at distances. For a couple questions, we will look at some angles. Now you can find this in your machine technology textbook. If you look, it's going to be page 434 to 432 in that area, so you can look up any questions there should you need to. Now we're going to start with a question where we're going to identify spaces between holes. I apologize if the image happens to be small for you, especially if you're working from a laptop or a phone. You may find you need to go to something with a little larger screen. So we're going to look at 5 holes equally spaced on a 5 and 200 thou diameter circle, and we're going to determine the straight line distance between 2 consecutive holes. Now without the diagram, this would be a challenging question to solve. I remember the first time I saw the question, and I certainly hope I'm a strong math person. I looked at it and said, how does this relate? But then once you see the triangle in the picture, it's a very easy question for us to solve. Now it's not unusual to figure out the distance between centers, and if we're able to find the distance between centers, we could also find the caliper measure from the edges of the hole if we were to need to, but in this case we're just going to find the center distances between two holes. That will allow us to do a layout. Sure, we might be able to find, the outside circle measurement, but if you go with the arc length, that's what we call the curved measurement, it's much harder to measure a curve than it is a straight line, especially if you're trying to measure accurately. So to solve this question, we start out with a triangle inside of our circle. So from the center of our circle, we're going to divide into a triangle. So the triangle, I'm just going to re-highlight this triangle in red. So we start out with a large triangle that connects 2 holes to the center. Now, if we took this circle and we did that with each pair of holes, we would find 5 holes will give us 5 triangles. So that will allow us to figure out what is this angle in the middle. So what we're really getting is we're getting 5 triangles. I'm going to see if I can re-sketch here. It's a little bit tricky to draw these lines. I'm going to try re-sketch it for you. So here's our triangle. I've just rotated it, so it might be a little easier to see. We have a right angle here on the bottom, and this is our angle we're finding up at the top. So if we have a circle, we know a circle is 360 degrees. Okay? So if we know a circle is 360 degrees, if we have 5 triangles connecting in a circle, each of those triangles, if these points are all connecting, the angle at the top is going to be 360 divided by 5. If we take 360 and we divide it by 5, we get 72 degrees. All right. Now that we have 72 degrees, we are able to continue with our calculation. So 72 degrees is this whole angle up here. Now you'll notice I divided, or the original image, the triangle was divided into 2. It's split into half, and it's split into half because we need a right triangle. And if we draw a line straight down from the center, this is kind of like when we did the V notch in the last lesson, you get a right angle here at the base. So we're really only going to work with half of our triangle at a time. So I'm actually going to adjust my line that I just wrote in. And we're going to say, well, we only want this much of the triangle, just half of it. So we're going to take our 72 degrees and we're going to divide it by 2. 72 degrees divided by 2 leaves us with 36 degrees. So this angle is 36 degrees. So a whole bunch of calculations just to figure out the angle. So you take your circle, divide it by the number of triangles that you would make in that circle if you were to split it into triangles. That gives us the complete angle, and maybe what I'll do is I'll put that one in here too, just so So if we were to do the full angle, the blue one is 72 degrees. So we've just split that into half. All right, now what we need to do is we need to find out some measurements. So we need to find the straight line distance between two consecutive holes. So our objective is to find this distance, the distance between hole 1 and hole 2. Okay, so we're looking for that distance. This is our x. In order to find that distance, we need to calculate the base of our triangle. So how do we do that? Well, let's go back to our picture. I'm going to erase a little ink here because I think it will help us out. So we're just going to eliminate a little bit of ink here. And we're going to think about some names. From the middle of our circle, so this is point O here, out to point B, label them the same way. From the center of the circle out to point B, this distance is a radius. So that means this edge here must be a radius. Well, how big is the radius? The radius is equal to half the diameter. So we take 5 and 200 thou and we divide it by 2. That's going to give us 2.600 inches. So that's our R. I'm going to leave the zeros off for the sake of space. So that's this length. So we have a side, we want to know the bottom, and we know our angle at the top. If you want to simplify it even further for your picture, I'm not sure why things are going crooked here. Bear with me. Hopefully it will improve as we go. Try to adjust angles on my tablet. So if we were to simplify the triangle even further, this is our radius, it's 2.6. Over here, we don't know this length, but what we want to find is the bottom, and this is 36 degrees. So that's maybe an even simpler way of writing it. So we've just gone from a circle to one triangle, and we take that triangle, divide it in two, and now we're just looking at half the triangle. So I've done that only just so to help us to label our sides. So we're going to label our sides using the names opposite, adjacent, and hypotenuse. So the 2.6 we can see is opposite the right angle, so this is my hypotenuse. Opposite 36 degrees is my x, so that's the opposite side. So going back to our ratios, sine, cosine, and tangent, which one uses opposite? SOH, CAH, TOA. If you're not sure, write it down. Sine uses opposite and hypotenuse. So we're going to find the sine of the angle of 36 degrees is equal to opposite on the top. So that's our x, or let's just change that up a little bit. I'm going to call that O. We'll just call that O, just because I don't want to have two x's for you. One x is bad enough in a question, two x's is worse. So we're going to call that O divided by our hypotenuse of 2.6. When we rearrange, opposite is equal to 2.6 times the sine of 36. If you put that into your calculator, you should get 1.528 inches. Now remember, that's just part of it. Okay, so that's just one section of the triangle. We split the triangle in half, so it's really, really important to double it. So x is going to be equal to 2 times what the measurement O is, 1.528 inches, which gives us, now sometimes you'll get a little rounding variation here. I usually will keep all of the decimals in my calculator. So if you're off by one place value, just look at that. 3.056 inches is the distance between holes. So a little bit of a long calculation. It's not really hard, but a lot of different pieces to take into consideration, which could make it feel challenging for you. We're going to do another example. In this question, it says 6 holes are equally spaced on a 4.38 inch diameter circle. Determine the straight line distance between two consecutive holes. Now this one I haven't given you a diagram, so we're going to have to draw our own. This could be fun. We'll see how well I do it at drawing a circle. So there's our circle. Looks more like an oval. There's the center of it. And I'm going to put 6 X's around the outside edge, kind of equal-ish. There we go. So there's our circle with our holes. We know the diameter of it, so the first thing we do is go back to like the original picture. We're going to make it into triangles. So let me change up colors again. And there's one triangle into the center, and there's our straight line distance, okay? As much of a straight line as we're going to get. So what we're looking for in this question is we're looking for distance x here. We need to calculate it. Well, from the center of a circle out to the edge, this is a radius. So a radius, we can find that right off the top. So the radius of this circle is going to be 4.3 divided by 2, which gives us a radius of 2.15. Okay, so we can put that in here. So we have that for our radius. We can figure out what the angle is here. That angle is easy to figure out. The angle is going to be equal to 360 degrees. Take our full circle and we divide that by how many triangles we would get. So this would divide into, you can see it would split into 6 triangles if we drew it out from each hole. So we're going to divide it by 6 and we get 60 degrees. Now let's take that triangle that we know a little bit of information about and redraw it and add in some new material. So we'll take our triangle. I'll leave it upside down this time. So here's our triangle. We know the radius is 2.15. I want to find out the length at the base, and we know the whole angle is 60 degrees. Okay, so that's the big angle. Now what we need to do is we need to figure out our right triangle. So we're going to look at just this half. Okay, just half of it. So I need to know what's the distance for across half that triangle, because that gives me a right angle. I can't use the whole distance because it wouldn't be right then. Wouldn't be a right triangle, and it wouldn't be a right number. And we can figure out this angle down here. If we cut the triangle in half, it's going to be half the whole angle, which is going to be 60 degrees divided by 2, so we get 30 degrees. Okay? So we have angle. This is my hypotenuse. So this is my hypotenuse. The x is my opposite, my distance there. So in order to solve it, we just put our information in our question. We already know that sine uses opposite and hypotenuse, so the sine of our angle is going to be opposite over hypotenuse. Putting the information in, sine of 30 is equal to opposite divided by 2.15. Rearrange it. Opposite is 2.15 times the sine of 30, which is equal to, I have it written down here, 1.075 inches. So x is equal to 2 times that, because that's we want the whole distance between holes. Maybe I shouldn't have used x over here. Okay, so we want the distance between two holes, the whole distance between holes. We cut our triangle in half, so we have to make sure we double it in order to go back to the whole distance instead of just halfway to the hole. So 2 times 1.075, which leaves us with a distance of 2.150 inches. Where else did you see a 2.15? It happened to be equal to a radius. Why is it the same? If you remember back And we could have used this principle, but I wanted to go through the calculation again. That's why I used it, but maybe I shouldn't have used something spaced equally in 6. If you have a 60-degree angle in a triangle, all of the angles in the triangle will be 60 degrees. If each of the angles in the triangle are 60 degrees, which in this case they happen to be, we have what's called an equilateral triangle. And if you remember, equilateral means all of the sides happen to be the same length. So it's good that we got the same distance for the radius as we did for the distance between two holes, because when we take a circle and divide it into 6 triangles, we actually get 6 equilateral triangles with all sides equal. So just one of those little tricks that we could have used at the beginning, but I really wanted to work through that math process again. Hopefully that helps you. You will have another practice question to try on your own to work at a little bit of that. It's a really, really, really great question to do. All right, the next questions we're going to look at involve the principle of a tangent. So I'm going to tell you what a tangent is, and hopefully you can use that. So a tangent is a line that's perpendicular or at a right angle to the radius of a circle. So here's the radius of a circle, so from O to P, and this tangent line just crosses the edge, and it makes a right angle with that. Okay, so we're going to use that quite a few times, that principle, and if you can remember that a tangent goes along the edge of a circle, and it's at a right angle to the radius. Okay, so anytime we have a straight line connect. All right, so how are we going to use it? We're going to use it for examples of V-slots, and these are tricky questions. They're easy once you see it. If you have a hard time visualizing, this will be a tricky one. I'll say that up front. I realize that. Again, like the other questions, there's a bunch of pieces we have to calculate. First time I looked at one of these, I went, how in the heck did they do that? So if you're thinking the same thing as we go through this lesson, don't be afraid, don't be worried. You'll be able to solve them. You just have to break them into simple pieces and use an example in the book as a guide. This question says, use the tangent principle to find the distance between points O and B. Then calculate the missing dimension x. So I've actually added an extra part to this question to make it easier. So it's not quite identical to the book, but the book calculates all the same pieces. We want to first figure out what's the distance from O, so the center of our circle, down to the bottom of the V. So that's the first thing we need to do. Then we're going to figure out what is this height over here. So we're making it a two-part question. We can't solve for this height unless we first get the distance from O to B. So that's the reason I've asked it that way. So you will see this particular image, a triangle has been added. What they've done is they've started at the center of this rod that's set into this V block, and they've drawn straight down to the bottom of the V groove. Then they said, well, okay, this edge of the V touches the edge of the circle. So the point where the circle touches the edge of the V makes a tangent. So that means if we go to the point where the circle touches the edge, touches the V, and we draw into the center, we get a 90-degree corner because that's what the tangent principle tells us. So this line, I'll highlight it, see if I can highlight it another color here. This blue line I'm adding right here, this edge is considered to be a tangent. And then in here we have our radius. Now because this is so small, I'm actually going to blow up some of our measurements a little bit, but before we do that, I'm going to add a few calculations. So first we're going to turn this diameter into a radius because we know we're going to need to have it. So radius is going to be equal to, we take 75 millimeters, we divide it by 2, So we're going to get 37.5 millimeters. You could keep your extra decimal in there. That would be a good idea. Make sure you do at the end. So that gives us our radius. So we'll add that in. And we can see our right triangle is just half of the V. So we're going to use a new angle here. Say our angle is going to be equal to half of 37 degrees. And half of 37 is 18.5 degrees. Now that's really messy to see. So as always, I like to kind of blow it up and look at it more simple. So here's our triangle. I seem to be improving as I go writing these. Okay, so here's our triangle, and we know the angle in here, this is 18.5 degrees. We know this distance is a radius, so it's 37.5 millimeters, and we want to know what's that distance. We want to know a side, and we know an angle. So in order to find the other distance, we need a SOHCAHTOA. Which one do we use? Perhaps you've taken a minute to look at your sides. Here's your angle. This is opposite. There's a right angle. X is opposite that, so this is my hypotenuse. So we have opposite and hypotenuse, so we're going to use sine. So the sine of 18.5 is equal to opposite, 37.5, divided by the hypotenuse, which is x. This is the one that people make mistakes rearranging. X is on the bottom, so we can't just multiply. This is the one that's going to stay as division. So x is equal to, these trade places, and if you just memorize the fact that if you're looking for the hypotenuse or x on the bottom of a fraction, it trades places with the other side. That's actually not a bad thing to have memorized. It's a good shortcut. You can do the long way of rearranging as well, but again, that takes time, right? So sine 18.5. Now that we have that, we can put it into our calculator. If you put that into your calculator, I'm going to trust at this point you can get that into your calculator. You might need to do 2 steps. You might need to calculate this first as a decimal. Keep extra decimals when you do, and then divide, but you should get 118.18 millimeters. So that's our distance O to B. So we just answered the first part. Okay, so it's not overly difficult, but just a lot of little pieces. So we just did the first part. Now it says calculate the missing dimension x. So we know that from the middle of this circle, this distance here is 118.18. So we know that's true. How in the world are we going to find x? Well, easiest way to find x is to figure out what is the distance all the way to the top. So what do we have to add in to get up to the top of x? We know that this goes from the center of the circle to the top, so that's going to be adding in another radius. So 37.5 needs added in. So to find x, we're going to take the distance from the bottom of the V to the center of the circle and add another radius. So 118.18 plus adding in a radius 37.5 gives us a length of, did I write that? Yes, I did write it down. Good. 155.68 millimeters. Okay, so now we know the distance all the way here is 155.68. So that goes up to the top of x, and we just need to subtract this little bit. So if we want to subtract that little piece, I know this little bit is just, if we take these two numbers, 222.5 minus 87.5, we'll find that this number is 135. Okay, so if I know the distance to the top is 155, I know this small distance here is 135. We're going to take our 155.68 minus 135 equals, and we will get a distance that is equal to 26.68 millimeters. So a bit of a complicated question, a whole bunch of pieces. Sometimes the hardest part, you might be able to find the distance to the middle, like that OB distance. You might be able to find this distance here, but then it's how do you use the rest? And you kind of have to look very carefully at your diagram and really think about how all those pieces go together. I calculated it one way. You may find you can get the same result using a slightly different order. At the end, it should all come down to the same. For example, I found out the height from the bottom of the V to the top of X. And then I found out what was this distance here, and I subtracted them. Instead, you could have found the distance all the way to the bottom and then subtracted the 22.5. Two methods at the very end that should get you the same 26.68. You'll have one to give a try with and see where you get with it. These questions do take a little bit longer. This one, we want to find the measure of angle Y if all these dimensions are given in inches. So we can use a rod of known diameter, put it into a V to see did we get the right notch. That might be important if you're figuring out the angle on a gear or something like that. How do we solve it? First thing we're going to do is we're going to make our triangle. It's not given us in this picture. So we're going to go straight down. Then we're going to see this is where the circle touches the edge of the V. So this is our tangent. Oh, I think that's going to stay. That's our tangent spot. So we're going to go from the center of the circle out to the tangent, and there's our right angle. So there's our triangle. Now we need to fill in some information. So we're always going to use the radius of the circle, so we can get that right at the beginning. The radius is going to be equal to half of the diameter, which is 0.3125. Okay? It's just my calculation. All right, so we have that. Now that we have that, what do we need to do with the rest? I don't have the angle, so I need to find two side lengths. So we know that this edge here is equal to the radius. I'll just put an R there for the moment. We'll put the number in after. Is there a way that we can calculate the length from the middle down to the bottom of the V? Well, it's actually not too bad a calculation. I'm going to extend these lines out. We know this distance here is 0.120. From the top of the circle down to the center is equal to a radius. So this is equal to 0.3125, and we know the height overall. So the distance from center of circle to bottom of V is going to be equal to 0.945 minus the distance to the top of the circle, which is 0.120 minus 0.3125. So all we're doing is we're finding out, we know what this total distance is, subtract a little bit below the top of the circle, and then subtract a radius to get you to the middle of the circle. This distance is equal to 0.5215. I'm going to redraw this triangle because you know I really like doing that to simplify the question. Oh, that's a terrible triangle. Let's undo that. Sorry, I just can't live with that one. All right. It's still a horrible triangle, but pretend that's a right angle. There's only so much I can do on my tablet to get things perfect. So we know this distance is from the center of the circle down to the bottom. We just calculated it. So it's 0.5215. We know that this is equal to a radius of 0.3125. And if I want to know the angle down here, it's an easy calculation. Opposite, hypotenuse. So the sine of our angle is equal to opposite over hypotenuse. Put the numbers in. Sine of the angle is equal to 0.3125 divided by 0.5215. And you will find you get an angle. Remember, you're looking for the angle, so you're going to use the shift sign. So it's going to be the inverse sign of the decimal, which is 0.5992. That's what I got when I calculated that ratio. And our angle is 36.81 degrees. Okay? So that's our angle. But you'll see angle Y goes the whole way through. So angle Y is equal to double that. So it's going to be 2 times 36.81, which gives us 73.62. Now, if you kept all of your decimals, you may have got 73.63, because I did that as well. If I kept every decimal, I would consider that to be correct. That's just a matter of not rounding early in your question. Not too bad a calculation, really, but there's multiple pieces. So it's getting a little bit more complicated. I just have one more example to do with you. Hopefully this hasn't given you too long of a lesson to work through. 2 pinballs are used to check accuracy of a dovetail. It can also be used to check the angles in a dovetail. If fabricated correctly, what should distance x measure? And I just lost my screen. I'm just going to pause for a second and resume. Sorry for the brief interruption there. Some eco-friendly computer technology decided to shut things down mid-recording. So sometimes pinballs are used to check. It can be used to check the measure of an angle, or it can be used to check to see, did you machine the angles correctly? So they've got 2 1-inch balls tucked in. We've got 2 1-inch balls here tucked in each corner of the dovetail. And by checking what the distance is between the two, we can figure out, are things set up right? Because you know what the angle should be, and by knowing what the angle should be, we are able to figure out what the measurement should be, and then go from there. Now, this is coming from your textbook. I don't have practical experience with this, so I'm not sure if it's something that you've seen yet in your shop. All right, so to do our calculation, you can see here we have a triangle happening again. Anytime a straight line touches a triangle, it makes a tangent. So we get this right angle. So we look at, where does the circle touch the line? We draw into the radius, and that gives us a right angle, so between the straight line and the point at our radius. So it's using a tangent again. We're going to blow this up. We're going to take this and we're going to blow it up over here. All right? Because we're going to need that to help us find out this x distance, because we need to know, well, what's this distance? Okay, the distance between, first we're going to find the distance between h and k, then we're going to find the distance between h and m, and we're going to subtract that because it's equal on both sides. So this is h and this is k here. This distance is a radius, and because they're 1 inch, they have a 1 inch diameter, we're going to have a radius of 0.5 inches. A nice and easy calculation there. This 72 degrees, 20 minutes, 2 places, gives us that both sides of these are equal. That's all that means, is it's equal. And that's the whole angle. Now you'll see here that we've cut this in half. Okay, so this angle happens to be cut in half when we tuck the circle in. So we're going to have to take our 72 degrees, 20 minutes, and we're going to divide it by 2. Now you know how to do that in your calculator. 72, the degree minute second button, 20, the degree minute second button, then hit divide by 2. You should get an angle of 36 degrees, 10 minutes. Okay? So that's what's going to go in here. So that's our angle. Now we figure out which trig do we need to use. So this is what I want to find. I want to find distance HK. So I have opposite, and this is adjacent. I don't have the hypotenuse, and I don't need the hypotenuse. So SOH, CAH, These ones are out because I don't have hypotenuse. We're going to use tan because it uses opposite and adjacent. All right, now let's do our calculation. So the tan of 36 degrees, 10 minutes is equal to opposite, 0.5, divided by the adjacent. Since, remember, we're looking for adjacent, it's on the bottom, so this is one of those trade places. Adjacent is going to be equal to 0.5 divided by the tan of 36 degrees, 10 minutes. The adjacent side, you should find, you get a value. I didn't write it down. Give me just 1 second to find our adjacent side. There we are. If you put that in your calculator, you'll get 0.6839997. Keeps on going. In this particular case, our measurements are all 3 decimal places. I see where I did write it down. So we get 0.684 inches. So that's from H to K. Okay, so we figured out what the distance is from here to here. Now we know H. Now we want to know H to M. So to get from H to M, we just have to add from the center of the circle to the outside edge, we add another radius. So 0.684 plus 0.5. And you get a value of 1.184 inches. So in order to find x, so now we know, put it in on the diagram. We know that this is 1.184. My 4 looks a little like a 9, I'm sorry. And this is 1.184. So because we have that, to find x, it's going to be equal to 6.312 minus 2 times 1.184. There, if I separate things far enough, it doesn't pick it up. All right. And as a final calculation, that should give us 3.944 inches. So lots of little pieces to calculate. You're kind of looking at, okay, how does that triangle fit into the middle of everything? So give a couple questions a try. The questions I'm going to give you have answers from the book. I'm just going to give you the book answers, and I will post video solutions for each of the questions that I give you for practice, because I think you may need some of the extra support for these ones. I think you would have been okay for the last lesson, but I think you'll need a little extra video for these. All right, quick lesson recap. Remember, a circle has 360 degrees. That will help you with those circle questions. So you're going to divide circles into triangles and then divide the triangle in half for a right angle. Remember that a tangent is created when a circular rod or ball is placed into a V-notch, and the radius and the edge of the V always will create a 90-degree angle. So you have a couple things that are new concepts, a little bit tricky, but just keep breaking it down. Try to keep it simple.